Okay, here we go. All right, welcome back to Mr. Morrell's Algebra class. Today we're talking about 1-6, and we're talking about absolute value equations and inequalities. Now, the good thing about this, just like regular equations and inequalities, the procedures for both types, either absolute value equations or absolute value inequalities, the procedures are going to be the same. All right? The only difference that we have to worry about, guys, if you remember, is whenever you multiply or divide by a negative to an inequality, you have to flip the inequality sign. It's the only difference. Now, let's talk about absolute value. We know, or at least I have taught you guys already, that the absolute value is the distance from zero. Very good. So let's just picture this. What's the absolute value of 3? What's the absolute value of -3? Okay. So would it be fair to say that when you have an absolute value, you have two sides of that? You have the positive side and the negative side? Would that be fair? Okay. If you could remember that the absolute value has a positive side and a negative side, you are going to love this. Let me explain what I'm talking about, please. For example, son or gentlemen, say solve. Okay. Let's say I have absolute value of 2x minus 1 equals 5. Okay. First thing we always got to do for every single absolute value, whether it's an equation or an inequality, you want to get the absolute value by itself. In this particular case, is the absolute value by itself here? Yes. How is it not by itself? If I go plus 6, then I got to subtract the 6 to get it alone, correct? If I was multiplying by 3, I'd have to divide by 3 to get it alone. If this was all being divided by 7, I'd have to multiply by 7 to get it alone. Great job. Great job. So step 1, get the absolute value alone. Okay? Once it's alone, now it's Mickey Mouse time. Remember how I told you guys you have a positive and a negative side? Well, check it out. I like to call the positive side the mirror image. It is the mirror image because that is exactly what it is. It is exactly the same as the original equation or inequality, but without the absolute value signs. So this means 2x minus 1 equals 5. That's the mirror image. Does that make sense? You promise? Okay. Now, the negative side. The negative side, multiply the non-absolute value side by -1. So, am I going to mess with the absolute value part? No. This is going to be 2x minus 1 equals -5. Excellent, thank you. Because this is the non-absolute value sign. So this is what you multiply -1 to. And now you solve, guys, literally. Plus 1, 2x equals 6 divided by 2. X equals 3. And add 1. 2x equals -4 divided by 2. X equals -2. So my solution, x could equal 3 or -2. Now, the one pain in the butt part of this, okay? When you have your solutions, you have to test them. Sometimes you'll get a solution, but when you test it, it's false. When you test a solution and it is false, that is called an extraneous solution. Now, let's see if we have any extraneous solutions for this example. Our answers were 3 or -2. Okay, so let's check. When x is 3, the absolute value of 2 times 3, that's 6 minus 1. What's the absolute value of 5? It's 5, so 5 equals 5. We're good. Also, we had -2, correct? Okay, well, 2 times -2 is -4 minus 1. What's the absolute value of -5? 5. 5 equals 5. Do they both work? Yes. If one of them did not work, that's when you say that is an extraneous solution. Yes, sir. No, thank you for asking. What he asked was, let's say you plugged in for -2, and instead of 5 equals 5, let's say you had 6 equals 5. Let's just say. Then for this case, you'd go solution is x equals 3 or -2, but then you go -2 is extraneous. So that's telling the reader, yeah, -2 is a solution, but it's an extraneous solution. But that's only if it doesn't work. In this case, they both worked, so there were no extraneous solutions. Yes, sir. Because 2 times -2 is -4. You got to plug it into the original equation, right? Thank you, my brother. Now, does that make sense, guys? All right, let me show you what happens with an inequality. And let's give you a little bit of a tougher one. Let's see. Okay, perfect. What if I gave you the following, gentlemen? 3 times 5x minus 1 plus 9 is less than or equal to 23. First things first, I have to get my absolute value alone. So what's the first thing I do here, brothers? Subtract 9. You undo addition and subtraction always. You may want to review your equation skills. So it's going to be 3 times absolute value of 5x minus 1. It's less than or equal to 23 minus 9 is 14. Now what, gentlemen? Divide by 3. So now I have 5x in absolute value minus 1 is less than or equal to 14/3. Is the absolute value alone now? Awesome. So now I break it up into my positive and my negative. My positive side is the mirror image. 5x minus 1 is less than or equal to 14/3. My negative side, I multiply the non-absolute value side by a -1. So I've got 5x minus 1 is now greater than or equal to -14/3. Why did I switch? Because I multiply by a -1. Thank you, son. Great job. Now, Mickey Mouse time. Add 1 to both sides. 5x is going to be less than or equal to, remember, 1 will turn into 3/3, right? And then that's going to be 17/3 multiplied by the reciprocal of 1/5, multiplied by the reciprocal of 1/5. X is less than or equal to 17/15. Add 1 over here, which becomes 3/3. So I've got 5x is greater than or equal to -11/3 multiplied by the reciprocal of 1/5. So x is greater than or equal to, bless you, -11/15. Now, we know how to work with these, okay? On my graph, what? Yes, but didn't I multiply by a negative? Remember we said that? So you had to switch. Didn't you multiply this side by a negative? So when I multiply by a negative, I got to flip the inequality sign. Thank you, son. Yes, sir. What? No, son. No. In the absolute value, there's the positive side and the negative side. When you're doing the negative side, you multiply the non-absolute value side by -1. Now, how to graph this? Well, this is going to be x is less than 1 2/15, and this is, that one's already in a fraction. So this is pretty easy to graph. Here's -1, -11/15 has to be here somewhere, right? And 1 2/15, here's 1, here's 2, so it's like about here, all right? So I have x is less than 1 2/15, less than or equal to, so I'm going to go to the left, less than, and it's greater than -11/15, closed circle, to the right. How am I going to write this in interval notation? I go small to large. -11/15, comma, 1 2/15, both brackets because they're less than or equal to or greater than or equal to. Yes? The other way for set builder? Well, for set builder, you'd go x is defined as x is less than 1 2/15, and or x is greater than or equal to -11/15, and you close it off. Yes, sir. For inequalities, you do not have to check for extraneous. Now, real quick. One thing that you are going to see sometimes, and you got to use your logic. If you ever see this, 2x plus 3, for example, equals -8, can the value of an absolute value ever be negative? So if you see that like this and the absolute value is all by itself already, it's no solution. You feel me? And also, if it's an inequality, you still can never be a negative. So whenever you have an absolute value equaling a negative, it's no solution. Homework is valid. God bless you. Thank you very much. Have a great day.